This lesson will teach me to set up and solve equations using angle pairs. So this is intended to be the second day of the angle pair lesson. So let's start with a quick recap. Complementary angles sum to 90 degrees. Supplementary angles sum or add up to 180 degrees. Linear pairs are supplementary, which means they add up to 180 degrees. Vertical angles are congruent. An angle bisector takes an angle and cuts it into two congruent pieces. Angle addition postulate is the idea of a part plus a part equaling the whole. And then adjacent angles, they really have no mathematical relationship. They just describe a location. All right, so what I'm asking in each one of these is for you to name the relationship and then find whatever it's asking. So first thing that I see here is a line. So these angles form a linear pair. Because they form a linear pair, that means they add up to be equal to 180 degrees. So at this point, it's algebra. So it turns into 8x plus 24 equals 180. And then from here, we solve, subtract the 24, divide by 8, and I ended up getting x was 19.5. And again, you need to be checking your math here. Please don't just write things down. Stop and actually do your work. It says the measure of angle TQS. So if I found that this angle here to be 19.5, then I plug it in, the measure of angle TQS, I have calculating as 137 degrees. For the next one, there's two different ways to look at it. I see that there's a 90-degree angle here, so that means this angle must also be 90. So I see angles that are complementary, which means they add up to 90 degrees. So I'm going to do 2x plus 3x equals 90, which gives me 5x equals 90, which gives me that x is 18. It's asking for the measure of A, B, D. So when I plug in the 18, sorry, it's not letting me write. There it goes. The measure of angle ABD is equal to 36. What a lot of students ask me is they say, well, aren't these angles adjacent? They are, but remember that adjacent is only describing a location, not necessarily a relationship. The other thing is that people will tell me is they say, well, I did this using supplementary angles. That works perfectly fine. If you're going to tell me supplementary, then I need to see that the 2x plus the 3x, not 30, 3x, plus that 90 degrees, that all of those end up equaling 180. So you have a different equation, but the answer will end up being the same. Looking at number 3, the angle relationship, I see two lines that are crossing. So these angles are vertical angles, and vertical angles are congruent. So my equation is those two things being set equal. Minusing the x is 38, and it looks like that's all it's asking for. All right, moving on. It says name the angle relationship. So what's happening here? I see a straight line. So I know that these things are supplementary because they form a linear pair. That's another question I get is some students say, well, why can't I call it supplementary? And I'm going to say that's great. How do you know they're supplementary? And the answer is that, well, because they lie in a line. So the best answer is linear pair. So I have the 100 plus the 30x plus the other 30x adds up to 180. So 60x is going to equal 80. X ends up equaling 80 over 60, which is 1 1/3. So I think that's all it asked for was x. I'm done. No big deal. Number 5, name the angle relationship. These are adjacent, but more importantly, I see these little curves. And how are those curves there, or why are they there? They're there because this thing must be an angle bisector. And what an angle bisector is doing is it's taking those two pieces and it's making them into it's taking the whole angle and it's cutting it into two equal pieces. So the piece labeled 9x minus 7 and the piece labeled 3x plus 17 are equal. So I'll subtract that 3 to the other side, add that 7 over, and I have 24. So that means x equals 4. Find the measure of D, B, C. So when I put a 4 right here, let's see, 12 added to 17 gives me an angle of 29 degrees. Wait a second. So my slideshow says DBC, but I'm looking at my paper and it looks like it's asking for the measure of angle ABC. So the measure of ABC is this whole angle. So if this one's 29, this one's 29, so the whole thing must be 58. I'm sorry, excuse me. All right, how many more? Not too many. Number 6, it says name the angle relationship. These angles are adjacent, but adjacent's not giving us anything but a location. Okay, they're side by side. They don't make a line. There's no right angle. They're not vertical because these lines don't cross perfectly. Vertical would have to be angle or lines that look like that. So I can't use vertical. The clue here is that it tells you that CBD, meaning this whole angle, is 157. The fact that it gave you a whole and these two parts is leading you to the angle addition postulate. And the angle addition postulate says that a part plus the part equals the whole. So that means that that part labeled 4x plus 3, when added to the piece labeled 4x, I'm sorry, I said 4, I meant 14x plus 3, labeled to the part that says 4x plus 10, it's going to equal the entire angle, which is the 157. So that's 8x plus 13 equals 157. Subtracting that 13, I said 8, I meant 18. 18x equals 144. And then when I divide by 18, I ended up with 8. And it just asks you for x, so you're done. Number 7, there's kind of a couple of things going on here that you need to see. Again, I see these curves, which tells me that this must be an angle bisector. So that this piece that's curved and this piece that's curved are the same. It's also telling you that ABE, meaning this entire angle, is 31x plus 15. But there's not just two angles, a part plus a part equals a whole. There's 3 pieces, and it works out that 2 of them are the same. So that 14x minus 9 can go here. So what you really end up having is the angle addition postulate here as well, paired with that idea of an angle bisector. I have the 9x plus 3 added to the 14x minus 9, added to the other 14x minus 9, and it equals the total that was given as a 31x plus 15. So when we combine like terms, I have 37x minus 15 ends up equaling 31x plus 15. So I'm going to subtract that 31 to the other side. That's giving me 6. When I add that 15 to the other side, that gave me 30. So x equals 5, which is all it's asking for. And then lastly, it says find the measure of an angle and its complement. So think about for a second, complement meaning complementary, meaning that I have 2 angles that add up to equal 90 degrees. I don't know the measure of the angle, so let's call it x. But I need the angle and its complement. It says one angle measure is 2 more than, let me switch colors, 2 more than 9 times the other. So this x stands for one angle, and I have no idea how much it is. But I know the other one is 2 more than 9 times it. What a lot of students do is they forget this first x and they say 9x plus 2 equals 90. But the idea of a complementary is we have two angles or more, but at least here they're saying find the measure of an angle and its complement, meaning we have two unknown quantities, one of them being x, the other one being the 9x plus 2. So that brings us to an equation of 10x plus 2 equals 90, 10x equals 88, x equals, what did I get 10? It's 2 more than 9 times the other. Yeah, no, I'm okay. 2 more than 9 times the other. So x is 8.8. It says find the measure of the angle. So 8.8, 2 more than 9 times the other. All right. And now what is 8.8 times 9 plus 2? I ended up with 81.2, and they add up equaling 90. I feel like I might have screwed something up. Find the measure of an angle, unknown, and its complement if one angle measure is 2 more than 9 times the other. I don't see anything. Let me know if you find anything. I think it looks good, but the biggest mistake you're going to make is you're not going to use both angles when you need them both. So that's it. Let me know if you have any questions. Thank you.